Tung tung. Okay, day 2 of final reviews. Remember when I promised you guys that I was going to hold at least one of my classes outdoors in these last 2 weeks? Well, this is that class. This is at least one of those classes. So I am currently filming outdoors, and you guys are required to view this outdoors. It's a literal requirement. If you don't do it, then you fail the class. Just kidding. But here you go. Here's proof that I am indeed filming outdoors. Hello. So yes, we are having our class outdoors, just like I promised. Guys, I'm so sorry about the coronavirus. This is really sucky, but hang in there. I'm still proud of all of you, even with the way the exam went. You guys are still doing great jobs, and hang in there. So we are working on problem 5 from the practice final. From practice final. One. And problem 5 is pretty straightforward. I wanted to be nice to you guys for once. So what are we doing? We just have a function, f of x equals 2x cubed plus 6x squared plus 1. And I asked the question, is there relative maximum? If so, what is it? All right. So, this problem is basically set up the same way that a lot of your homework problems from these sections were set up. And the idea is that where would a relative max occur? And of course the answer to that is at a critical point. So that changes our objectives to find a critical point. Really, hence we want to find all the critical points. And then this is something that I think a lot of you guys forgot on the exam, is that relative maximums have very special things that happen about them. What's special about a relative maximum? How can we prove it's a relative max? I should say, how do we know it's a relative max? And the answer to that is that the function has to be concave down there. Concave down at the critical point, also known as f double prime of the critical point is negative. So these are really the two things we need to find. We need to find critical points of f of x, and we need f double prime at that critical point to be negative. After that, we're good to go. So let's do it. Let's find critical points. How do we find critical points? F prime equals 0, solve for x. This is like, I would say like the number Probably the number one thing you want to remember from, I mean, I guess the power rule of derivatives, right, is the number one thing, but this is probably the number two thing then, I guess, you want to remember from calculus, is you take a derivative, set it equal to 0, and solve for x. So we're going to do that. So what is f prime here? F prime, very simple problem that I gave you guys. 2x cubed plus 6x squared plus 1. What is it? It is 6x squared plus 12x. Set it equal to 0, solve for x. So how do we solve for x? We're going to factor out 6x. We get 6x. X plus 2 equals 0. So x equals 0. X equals negative 2 critical points. Okay. That was only half of my problem, right? Because the other half of my problem said I need the derivative to be negative. So we need f double prime crit point less than 0. So we need to find f double prime of x. Well, thankfully we found the first derivative right here, right? First derivative, bam, done. So the first derivative, I'm going to circle that, pull it down, we're going to use that. F double prime of x equals 12x plus 12. I don't really need that to be equal to 0. 12x plus 12. Hence, f double prime of 0 equals 12. Well, that's positive. That's bad. F double prime of negative 2. Well, that's negative 24. It's less than 0. Good. Okay, so there you go. We have a negative second derivative at one of the critical points. Hence, really negative 2, f of negative 2 is our critical, is a relative max. Plug it in, f equals negative 2. If you actually evaluate it, this is also equal to 9. So 2, 9 is a relative max. And that's the answer the exam gives. So I mentioned this the last time, but I'm going to reiterate it because I can't stress this enough. Do problems like this first. They're quick and easy. And worth just as many points. As longer problems. Okay, so that's a really good thing. You just seek out those easy problems and get them done right away. All right, let's move on to problem number 6. Problem 6, pretty straightforward again. Newer material, but still pretty straightforward. Right, I'm not going to be mean to you guys on every single problem. I think you've seen that in the past. I'm only mean to you on some problems, and you just want to take a critical eye to everything and hopefully you can recognize which ones I'm mean to you on and which ones I'm not. So this is pretty straightforward. It says let f of x be x, absolute value of x, not squared, absolute value of x divided by 2. And g of x is 5 minus x squared. It says find the total area bounded by the curves f and g. bounded between f of x and g of x. Really ask the question, what is the total area? But yeah, find the total area bounded between them. And we've just completed this chapter in the book a week ago, this section in the book a week ago. And the way it's solved, you'll remember, is find the first step. This is the steps to solve it. Maybe I'll write it in a different color so you guys don't get it confused with me solving the problem. Steps to solve a problem like this. So step 1, find intersection points. This is, you set f of x equal g of x, you solve for x. You could also graph. You could also find these by graphing. And, you would literally find the intersection points if you graphed it. So either way, we're going to find the intersection points. And then 2, we're just going to integrate from the lower intersection point to the upper intersection point. And then this is the special part, right? This is top curve minus bottom curve dx. Should feel very familiar since we just did this a week ago. Top curve minus bottom curve dx. Okay, so let's do that. Let's do step 1, find the intersection points. X over 2 equals 5 minus x squared. Okay, you're going to start to freak out because you see an absolute value sign. I'm going to help you out here. Don't freak out when you see an absolute value sign. Okay, just split the problem between x less than 0 and x greater than or equal to 0. Okay, you just make one problem into 2 smaller problems and you're fine. So let's just do that. So x less than 0, the absolute value sign becomes minus. Well, what do I do here? I add x squared to both sides. I'm just solving for x right now. X squared minus x over 2 plus 5 equals 0. I'll multiply everything by 2. 2x squared minus x plus 10 equals 0. Once again, I'm going to use a quadratic equation. It's honestly faster a lot of the times than trying to factor something. So negative b is 1 plus or minus the square root of b squared, 1 minus 4ac. 4 times 10 times 2 is 80. All over 2. Did I add something wrong? Yeah, there should be a negative sign here. Silly me. These are negative signs. Plus, there you go, all over 2a is 4. Makes sense that I'm taking the square root of 81, right? It's something you can actually take a square root of, and I only set up good problems for you guys. 81, the square root of 81 is 9, if you've forgotten. This is 1 plus or minus 9 divided by 4, so we get 10 fourths or negative 8 fourths. So you get either, which one of these is true? this is a good question for you guys right now. Which one of these two numbers is true? Think about it for a bit. I'm going to scroll up. Heyo. X is less than 0. Since x is less than 0, it's -8/4, which is -2, is the intersection point. There you go. So one intersection point is -2, and then we do this x greater than 0. We do the same thing with x greater than 0. So for x greater than 0, it changes our problem to x over 2 equals 5 minus x squared. And we're going to solve that the same way. X squared plus x over 2 minus 5 equals 0, also known as 2x squared plus x minus 10 equals 0. Quadratic equation. X equals -b plus or minus the square root of b squared minus 4ac. Once again turns into plus 80, all divided by 2a divided by 4. Now this becomes -1 plus or minus 9 divided by 4. And so this is going to be -10/4 or 8/4. Which one is it? Same as before. X is greater than 0 now, so 8/4 equals 2 is our intersection point. So hence our intersection points are -2 and 2. So that brings us to step 2. Step 2 of my lovely step process here. Integral of upper intersection point, or well, lower intersection point to upper intersection point, top curve minus bottom curve dx. Now is where a graph will help. And it's fine, you guys can use a calculator or Wolfram Alpha. To get yourself a nice graph of these functions. You should be able to do it anyway, but it doesn't kill me that you can't. This is absolute value of x over 2. And then this one, here's 5. 5 minus x squared looks like this. And there's our 2 points. Points happening at -2, 1, 2, 1. And so this is of course 5 minus x squared up here. Hence, the top curve is 5 minus x squared. The bottom curve is absolute value x over 2. This gives us our integral from -2 to 2. 5 minus x squared minus absolute value x over 2 dx. But you see an absolute value sign, you guys freak out again. Oops. So don't freak out. We've done this before. It's going to make sense when you see it again. Split the integral. at 0. I mean, it's the same thing I said above, right? Every time you have an absolute value sign, you're actually computing two problems. You're computing the x greater than 0 problem. You're computing the x less than 0 problem. So this is the same thing here. You split it into two problems, x greater than 0 problem, x less than 0 problem. Turns into -2 to 0, 5 minus x squared. On the negative side, the absolute value picks up an extra negative sign. So here that'll give it a plus x over 2 dx plus integral 0 to 2, 5 minus x squared minus x over 2. That's how you're going to play with the absolute value sign here. And everything else is just the power rule. So the power rule there is giving me 5x minus x cubed over 3 plus x squared over 4, evaluated at -2 and 0. This is giving me 5x minus x cubed over 3 minus x squared over 4, evaluated at 0 and 2. Compute these as you always would. The 0 terms, definitely 0. And then minus the -2 terms. So this is -10 minus, so plus 8/3 plus 4/4. And over here we have 5 times 2 is 10. It's 10 minus 8/3 minus 4/4 minus 0. So you collect your like terms. Well, you can collect all the terms. We have two negative 10s, so we really have 20, and we have the 8/3 cancel, and then the 4/4 cancel. So we get 20, but that's not the right answer. So I have something wrong here. Yeah, there are two sets of -8/3 actually. That's my computer being really angry. 16/3 and the 4/4 actually. I have two sets of -4/4 as well. I don't know what I was doing. So -2. So this is 18 minus 16/3. 18 is how many thirds? I guess it's 54/3. 54 minus 16 is 38. 38/3. I hope that's the right answer now. 38/3 is the right answer the sheet gives, so we're good to go. The answer the exam gives. So we are good to go on that problem. Yeah, so hopefully I can assuage your worries about absolute value signs now. You just split the problem into two problems. Gives you a little bit of extra work, but it's not certainly never impossible to work with. So we're with problem 7. This one is a bit trickier. I was a little mean to you guys. So I wrote down f of 0 equal 1. Wrote down g of 0 equal -1. I wrote down f of 1 equals pi. And I wrote down g of 1 equals 1. I then say, further, we have that the integral of f prime of x, g of x, dx from 0 to 1 equals pi. What we want to solve is the integral from 0 to 1, really of the opposite of the integral that I've given you. It has f of x, g prime of x, dx. So this is abstract. It's very abstract, and you might be worried right now. Yeah, I write hard problems sometimes. What's going on here? We have an integral. I'll write that down. What's going on? There's an integral And every time there's an integral, there's only two ways that we know how to solve it. You can either solve with u sub, or you can solve it with integration by parts. Well, if we let's just suppose we're going to do this with u sub. Suppose we're going to do u sub. What and go through priorities. Let's go through the priorities. Go through the priorities for u. Priority 1, natural log x if it exists. Certainly not. Priority 2, denominator if it exists. No way. Priority 3, exponent of e if it exists. Once again, doesn't exist. Number 4, piece in parentheses. So if this were a u sub, the piece in parentheses would have to be the thing we're choosing. I mean, I guess there's an x in parentheses, but no, there's absolutely nothing here in parentheses. There's no way to make this a u sub problem. So we're going to make this integration by parts. And if you'll remember, the way that we perform every integration by parts problem is we have steps for this too, right? We have steps for integration by parts problems. Do this in blue. Step 1 is identify u equals, and then we had priorities here. And the priorities for u with integration by parts also aren't going to apply for the same reasons. I can just jump to the top here. They're not going to apply for the same reasons. The same reasons why u sub wouldn't work. So we start to feel really screwed here. So the real question is, what should u be? Well, anyway, let's finish our steps. So that's step 1. Step 2 is I guess dv equals everything else. Step 2 is to actually calculate du equals and v equals. And then step 3 is to write down this uv minus integral v du. And then step 4 was actually solve it. Solve the last integral. Okay, so let's see if we can somehow make this work here. So I need to choose u equals something, dv equals something, so that I can find du equals something and v equals something. But the special thing about v equals something here is that v always equals the integral of dv. And in my problem, the problem up here, integral from 0 to 1 f of x times g prime of x dx. My problem is problem asks integral 0 to 1 f of x g prime x dx. Well, if I'm going to integrate, so let's just throw it out here like this. Clearly, u equals f of x or u equals g prime of x. If u equaled f of x, then, so I'm going to separate this here. If u equals f of x, then du equals f prime of x. dv equals g prime of x dx. And over here, if u equals g prime of x, then du equals g double prime of x, and dv equals f of x. So what would that make v in this case? V in this case would be g of x, and v in this case would be the integral of f of x dx. One of these two looks better than the other. That's all I have to say. One of these two choices looks a little bit better than the other, and I think everybody can agree that in this case, and that in the case on the left, those are all terms that we kind of have seen. Single prime, we just have f prime, g, and f. But in this other case, we have g and g double prime, and we have f and the antiderivative of f. And I don't think anybody wants to work with this g double prime because we're not given those values. And we don't want to work with that because we're not giving those values. So we don't want to work with these sorts of terms. We aren't given these terms, so they're bad. Likewise, though, we're given all of these. So because of all that, we let u equal f prime of x, u equal f of x, du would then be f prime of x dx, dv would be g prime of x dx, so then v could be g of x. I feel like I missed, I missed dx here. But there you go. So once we do that, this is step 2 basically. This is step 1 and 2. So that's 1 and 2. So step 3 says you write down uv minus integral v du. Well, what is that here? That's uv fx g of x minus the integral v du. V is g of x, du is f prime of x dx. Well, you'll remember, where were we evaluating things originally? We were evaluating at 0 and 1. Evaluate at 0 and 1. So we do that here. Step 4, evaluate at 0 and 1. So what do we get? We get f of 1, g of 1, minus the integral. Well, here's how I'll write this. I'll write it like this. F of x, g of x, evaluated at 0 and 1, minus the integral evaluated at 0 and 1, g of x, f prime of x, dx. Do we know all of these terms? Yes, we do, because these were all given to us. So all of these terms were given to us at the beginning. And so we just plug them in, right? So this is really f of 1, g of 1, minus f of 0, g of 0, minus this integral term. And I'm going to scroll up and then we'll see what it was. Gx, f prime of x, dx. So I scroll all the way up, look at the beginning. f1 is 0, f1 is pi, g1 is 1, f0 is 1, g0 is negative 1. So this is pi times 1 minus 1 times negative 1 minus pi. So the pi's cancel, and I'm left with negative 1 times negative 1. I'm left with 1. The answer the exam gives. So there you go. That's a pretty crazy problem. And you're also getting new at integration by parts, but that's why we have 2 weeks to prepare, right? 2 weeks to prepare. Let's handle this last problem, and then we're done for the day. Problem 8. Problem 8 says, you're building an open box by cutting squares out of the corners of a 2-foot by 2-foot rectangular piece of cardboard. I guess 2 feet by 2 feet is indeed a square piece of cardboard. 2 feet, 2 feet, and we're cutting squares out of the corners. You guys will remember this problem from our class period. Cutting squares out of the corners. I'm going to give my squares length x, but then we're folding this up to an open box. So when it gets folded up, it'll look something like that, and then this will drop down because it's open. So I'm not going to label the sides there yet because that's something that we're going to do when we go through the problem. It says, what will the dimensions of the final box be that maximizes the volume? And here we see the word maximize, and that should really tip you off to say this is an optimization problem. Which means if it's an optimization problem, you need to take a derivative set it equal to 0 and solve for the variable. So many points that I give out will be dependent on you doing this. Most of the points I give are dependent on you doing this. So do it. Okay, let's maybe draw out the lengths, label the lengths here of this box that I've put here. If it's 2 feet by 2 feet, what are these lengths? Well, how many X's am I actually cutting out? I'm going to put another X there. So that means that this length here is 2 minus 2X because I've cut out 2 X's. Since I've cut 2 X's from the sides. And that gives the same length here, 2 minus 2x, which means when I fold up my box, my width is 2 minus 2x, my length is 2 minus 2x, and my height, what's my height going to be? If I look up there and think about folding it up, my height's going to be x. Thus, if I want to maximize the volume, I need an equation for the volume dependent on x. Well, it's length times the width times height. What is my length? It's 2 minus 2x. What is my width? It's 2 minus 2x. And what is my height? It's x. So let's actually, rather than taking a triple product rule, I would rather just get this all hammered out. This is 4 minus, I believe that's 8x plus 4x squared times x. So this is going to be 4x minus 8x squared plus 4x cubed. And now I get to the fancy take a derivative, set it equal to 0. V prime of x is going to be 4 minus 16x plus 12x squared equals 0. I'm going to divide all by 4. Make my life easy. What do I get? I get 1 minus 4x plus 3x squared equals 0. And now I'm going to do that quadratic equation nonsense because I do not get paid enough to try to factor that. Negative b. Now, I've written it backwards now, so don't get screwed up because I've written it backwards. Negative b is 4 plus or minus the square root of b squared is 16 minus 4ac is 4 times 3 times 1 is 12 all over 2a. So remember, my a is the term with x squared. So it's 2 times 3. This is a 6 here. This is 4 plus or minus the square root of 4 divided by 6. I get 4 plus 2 over 6, or I get 4 minus 2 over 6. So what is that? That's either 1 or 1/3. Now this is where you have to have some critical thinking. Which is it? Every time you do this quadratic equation, you're going to be asking yourself which one of these is actually the true answer. So which one is it, 1 or 1/3? Well, let's approach the problem again. Let's look at our box here. Well, let's not do that box. Let's do the big box. This was x. This was 2. That made this 2 minus 2x. If x equals 1, if x equals 1, then we've cut the entire side off. Right? X equals 1 corresponds to me putting my cuts right there. Those are my this is my X here. So X equals 1 is bad. So that makes X equals 1/3 is good. But this doesn't give dimensions. So dimensions are 2 minus 2/3 by 2 minus 2/3 by 1/3, because this is the box that we're actually making. So what is that? That's really 4/3 by 4/3 by 1/3. And indeed, this is the answer given. So there you go. There's the first final exam. It's a little tough. Some problems are pretty crazy, but I'm giving you 2 weeks and all of these reviews. And who knows? It might be a little bit easy if you practice hard enough. All right. See you tomorrow. Bye.